as I said, I'd like each of you to think about that you're the person that's going to build a building. As you walk around this show, we're going to be involved with what? Our own companies, our own messages. So in a group, I like to say, let's focus. When we're trying to talk about, oh, you're going to build a building, I'm not talking about building a hospital. I'm not talking about doing a college campus. I'm talking about a building that you are going to own, you're going to build. You haven't built it yet. So what are the things that go through your mind? And probably the first thing that goes through your mind is you want a really energy efficient air conditioning system. Maybe those of you in this room think about that, but most people don't. If you go through the list of things that are important, energy efficiency kind of falls to the back unless that happens to be the business that you're in. Smart green technology, but all those things in orange are really what you're thinking about. What's in the street, what's available to me, where are my customers, where are my employees going to come from, etc. So today we're going to talk about how can we help an owner of a building, whether it's commercial or residential, actually be a part of, we'll call it the fight against climate disruptions. We don't want to get into an issue about fighting climate change. We're talking about how do you handle these climate disruptions that we're dealing with. So we may not be your focus as a building owner to begin with, but your asset managers, your team, they're thinking about what are we going to do about this part of it with all the political push. And what I'm going to talk about today is one narrow kind of a solution that's existing that isn't necessarily available to all of you that are building smaller buildings or all of you in your homes, but it's possible. And from this discussion, I'm going to try to stay focused, which is difficult, but you can think about all the different variations of things that can happen. And what I'm going to talk about is what I call an environmental neighborhood. When you decide to build your building, what are you looking for? Well, what's in the street? Are there roads? Are there curbs? Is there power? Is there gas? Is there not? Sewers, water, whatever. All of these different things enter into what is going to be your cost. So if your property manager comes to you and he says, oh, they have district heating, what does that mean to you as an owner? That means you don't have to put in a big boiler, or you don't have to worry about how they're heating, because that's something you don't have to allocate money to. And in most major buildings in cities across America, what do you see? Cooling towers on the roof. They have condenser water running around the building. And why is that? Well, it's roof space, it's exterior space to get to air conditioning, but it also means higher efficiency air conditioning. It means that when I buy equipment, it's going to last longer. It means that it's going to operate more efficiently because it's not fighting outside air. Our HVAC, outside air temperatures. So in our business, we have the outside, the source or the sink, and we have the inside. And I'm in the geo-exchange business. What's the advantage of geo-exchange? Everybody gets a low utility bill. What's the disadvantage? If you want it for your building or your home, you get to pay for it. So what we're going to talk about is, what if that's in the street? What if that water is in the street already? So this is infrastructure. What is the purpose of infrastructure? It's to do the things that you can't do. When you think about a hospital, when you think about a campus, you think about what? They're taking advantage of a central plant. When you look at large buildings in your city, wherever you live, what are you thinking about? They have the central plant advantage. I can't put a central plant in a small building. I can't take care of it even. And in rural schools in Oklahoma, we see residential units being put in a school. But why? The nearest guy that can service their equipment is a residential air conditioning guy. So you see condensing units and gas furnaces because they need the resilience. So we're talking about infrastructure, and I'm going to talk about one approach. And it doesn't mean this is the silver bullet. It means this is an option that's becoming more and more available as more and more states and districts start talking about it, a different type of district solution. So the goal we're talking about is how, as an owner, can you spend less and save more? Get this cost off of your back through infrastructure. And what that's called is a thermal energy network. And why we talk about it, and this is one of my favorite slides, is we have to stop polarization of thought about how we're going to resolve something. We need to work together to use whatever resources we have. If you look at this chart, what's horizontal? Commercial use of gas, residential use of gas. What's not horizontal? Electric power consumption of natural gas. Since the 70s, when I would pull up to a gas station and couldn't get gas, I didn't argue about how much it cost. I couldn't get it, period. We've been electrifying in the United States, but how have we been dealing with it? We've been dealing with it by burning more and more fossil fuels. This is not an argument about that. This is a discussion about what can we do, and what needs to happen is that utilities need to work together. There needs to be more coordination, and we need to get away from polarizing utilities against each other. We need, for resilience, we need choice if we're going to look at the issues. So, consumers, as you as a building owner, you're affecting one part of it, your consumption. Unfortunately and sadly today, with the issues in Turkey, we're dealing with more and more disruptions. And if you want to avoid a conversation about climate change, the easiest thing to talk about is climate disruptions. The magnitude is higher and lower, the duration is longer, and the result needs to be that we need to have a way to deal with it. How do we deal with these changes? And I get this editorial every Wednesday morning from a woman named Amy Harder, who is the executive editor of a magazine called Cypher. And she made a comment that I want you to think about. She said, "Why I sometimes begrudgingly conclude we must look to capitalism and the innovation of new and better technology to save us." When I first heard that, I went, we already have new technology. What we don't have is it's universally applicable to everybody. And we do have, unfortunately, capitalism that drives us to do things that are narrow in thought process. But thanks to COVID, I guess, and the increase in the number of actual presentations that I can log into, Dr. Linda Stagg, who is an environmental psychologist, played on this idea of we can't sacrifice our way out of climate change. That hit me because I remember in the 70s putting heat pumps in a school that only had a heating system, and all of a sudden they were excited that they had a two-pipe system that it would heat and cool, but they want to know how come their bill was higher. Well, your bill is higher because you now are more comfortable. We all want to be more comfortable. So before you went, well, the air conditioning system won't do it. We don't have air conditioning. In fact, in those days in Washington State, schools were limited to a two-pipe system. Of course, that regulation was based on two-pipe boiler cooling tower, boiler chiller type of application. So anyway, the point is, as all of you taking away from you being a building owner right now, you are, whether you realize it or not, you are the expertise in your circle of influence. So I want you to know about a way, about something that can come from the ground up, from localities up, and give owners an advantage to get in to really addressing how much energy they're using, how can we serve those that are underserved, and remembering that those that are underserved aren't causing our pollution problems. They're not using the energy, but they deserve to be served. So this is city managers. This is a thought process of your neighborhood and what are your advantages. This is called a thermal energy network. It's a variation on a district system. The district, instead of supplying hot water or steam or chilled water, is ground temperature water. Essentially what it is for someone like me that's in the heat pump business, it's the sweet spot. It's where heat pumps work really great. I'm not applying them at extremes, but think about the condenser water loop that was in the large building. It meant every air conditioner worked better. Every coil worked better. Okay? So that's what we're talking about. As you as an owner, lower cost, lower operating costs, what's the ROI when I didn't have to pay for the infrastructure? We get involved year after year after year talking about return on investment. Well, what if that infrastructure investment wasn't yours? It was a fee. Well, it wasn't a capital cost. Now it's an operating cost. And physically, what it means is there's a pipe. It can be one, it can be two, running out in front of your building. So when you pick the site to build your building, you're looking at streets, you're looking at water, you're looking at sewers, you're looking at energy efficiency in the street. You're going to pay a fee for that, but the electric utility will still bill you for power. If you still need natural gas or have it available, you're still going to pay natural gas, but you're going to use less, because the purpose of a thermal energy network is to use less. It's not more for more consumption. It's not how do we address handling this growth. It's how do we use less electricity, less power. And you do it by making your building more efficient. You make it that way by sharing energy among buildings. As we get our buildings better and better and better, what do we deal with? What the United States has been focusing on for the last 50 years I've been in this business is cooling efficiency. It's kind of like after boilers could get to 95%, we sort of gave up on can we get heating cheaper. Now we're thinking about, well, how do we do heating without on-site combustion of gas? I played a game. I opened up my computer. This is my hometown, Edmond, Oklahoma. And I said, search public schools. That's all the red dots. The orange ones are just places I like to go out to eat. They just happen to show up. And on the left is what I want you to understand about greening of a thermal energy network. We talk about greening the grid. A thermal energy network is pipe among buildings. Each of those buildings is a source or a sink for heat. Once your building becomes net, in other words, this encourages the building owner to trade energy inside his building first. Not just HVAC, but HVAC and water heating. And many of you may not know, there's equipment right now that you can interface with your black water, not just gray water. So in the building, we move ourselves to a net. Then among buildings, you move to a net. So that if you have a district for makeup, backup, startup, that your building will eventually become part of a network, then you can have energy efficiency without the cost. How does this work? Bidirectional, meaning I'm going to take heat out of the water, I'm going to put heat in the water. This is what's been done with water source heat pump buildings forever. What do they have? Central gas boiler is the biggest commercial. Then you have a cooling tower of some kind. In the early days, we used swimming pool heaters and open towers and PVC pipe. It wasn't such a smart idea. But it's been done for 50 years. This is better technology, better pipe, and the same logic of saying, when we start up, how are we going to get this to work? Because we can't do it by ourselves. We can deal with our own building, but this is a new type of infrastructure because it's about heat capture. Heat capture is how we will address decarbonization. If we're worried about cooling, well, let's get our cooling efficiency up, and then let's capture the heat in the building and use it in our building first, and then share it among other buildings. In fact, the network could even have a logic that says, we want you in the network. Why? Because you're a grocery store, and you have refrigeration running year-round. You have more heat that you can use. Down here, next to you, is a fast food franchise, a restaurant, assisted living, multifamily housing, and they are heating 40 gallons of hot water a day per person. You have an office building. You're maybe doing 2. So you don't have use for your heat, although when you're occupied, you do have that heat. This is heat capture. I put this up as a local advantage and a couple of cartoons so you can think about something, because I think the way to make this all work is that when there is a sewer renovation or new sewer lines to be laid out, the very logical place to put the thermal energy network is in the same ditch. Those water temperatures want to be the same. They want to be the ground temperature. Sewer water is getting hotter and hotter. Low flow urinals, toilets, showers means less cold water mixing with your hot water. More and more buildings are looking into rainwater retention. Fighting fires, flushing toilets, those are all water sources. But when you first start out to look at this thermal energy network, and you have a logic that says, I want to green it, where can I reject heat? Where can I take heat from? Where can I get heat from? The logic on a thermal energy network isn't, how do I make sure the hot water gets to the building? How do I make sure the cold water gets to the building? Insulate the pipe, insulate the pipe, insulate the pipe, service the pipe, versus a simple, lazy loop of water going around and around past these buildings. Anybody that can design a 20-story office building can lay out one of these systems. But what has he got to deal with? Who's going to put the pipe in the ground? Who's going to manage it? Who's going to make this all work? In my version, my one version of this, the sewer district manages it, because you're still going to pay electrical, and if you need gas, you're still going to pay a gas bill. So that's that energy. The advantage that's coming to you from the water district is negotiating power on your fuel costs, and they're able to go to their board and say, we're going to invest in infrastructure to use less. If you're a gas utility or a power utility and you say, we're going to invest in infrastructure to use less. Why? Well, because it's demanded, versus the water utilities, the water jurisdiction saying, we're going to invest in this because it's good, because they're going to use less, because this is going to create this environmental neighborhood. This is positive for us, And you as a building owner look at it and go, that money goes to the water district to improve my own water and my own sewer quality in my environmental neighborhood. So this isn't new. It's just in the beginning. Here's an example from a contractor that was going to be here this morning, but he couldn't make it. But this is just a downtown business district. There are 54 buildings together on a 14-inch main. 14. It's easy enough to design, and it's being done. It's not new. Sharing is the key. Here's a little town on the left that I used to go to when it's too wet to bale hay and I'd go to a movie. I wanted to show you, here's 700 homes. Those lines are all the sewer district system already. There's already a network. There's already right-of-way. There's already the work that goes through to lay out a sewer. If you've been a developer, if you put in a new development, all that ground study, all where the water runs, all the handling of the watering, and if it's going to be geothermal, an approval process that involves how are we going to green this network with geothermal or geoexchange or a river, or Toronto lakes, Denver sewer, a big project for their Western Convention Center. So when you look at every city and you think about the ditch, they have what's called stationing. So it describes where the sewers will go, where the manholes are. It's a code. Here's where it is. It's very easy to add this thermal network to that. I look at the one on the right and I go, oh, there's that little thing down there at the bottom below that sewer treatment plant that says bypass. I don't necessarily like that. I happen to live down the stream of one of those. So why does this work? As a building owner, as a homeowner, what's the temperature of water that comes into your building? Its biggest effect is the ground temperature. But the biggest thing for me as a manufacturer is when I make a heat pump, I make a water source heat pump, if I'm dealing with what the top graph is showing, I've got a range of 35 degrees or 40 degrees that I'm trying to get equipment to operate in and function properly. The bottom screen, what you can't read is that's the differential between the lowest historical temperature recorded and the highest temperature recorded. So if I'm going to give you a resilient product, do I just tell you I only deal with when it's hot and I only deal with when it's cold? And that's why we end up with heating plants and cooling plants. We end up with a challenge to try and make equipment that will handle both. Is it only going to be good here? Is it only going to be good there? The idea of this thermal energy network is let the outside temperature, let's mitigate that. You already did it in your building. You already insulated your walls. You already picked windows to mitigate that difference. We need to be doing that with our air conditioning system. And you, in this room, I've tagged you as building owners, but you are all experts in your circle of influence, not only professionally, but personally. This is something people need to understand can be driven locally. We're not waiting for the federal government to come down and say, we're going to give you a blanket policy. What's the problem with the federal government? Is that we deal with averages. None of us are average. We're either below, unfortunately, or we're above. But our building isn't built to be energy efficient. Our building is being built to be a productive building. And it may be contrary to what people want, but it's why I paid to come to a hotel. I expected it to do this. I expected it to do that. Yeah, in the 70s we did, and there are places now, of course, that are saying, hey, you can't use all the water you want, and we're only going to have heating or we're only going to have cooling. But this works. This works because you're not fighting outdoor air. You're dealing with something that's more stable. And quite frankly, the point of it being a district means that it can have a way to add heat or remove heat from this loop that's going around to your buildings. So it's not going to heat the ground up because it's not going to be allowed to get too hot. And it's not going to cool the ground too much because it's not going to be allowed to do that. And with that list of things that I gave you that are on the left, all the different ways it can be greened by really anything that's hotter, colder, or the same temperature as this ground temperature loop that we want. And it already wants to be there. We're not trying to deliver cold water or steam or hot water. We're not trying to get, those of you that work with big chiller plants, we're not trying to get big delta T's. The ideal delta T for a thermal energy network is 0. It went to your building and you put heat in. It went to his building, he took it out. You put it back in, he took it out. You put it in, you took it out. Oh, it's getting built up. We've added geo-exchange, and for those of you that I use that word, you hear geothermal. Geothermal is nothing but a heat exchanger in the ground because the ground temperature is favorable to making DX equipment cool and very favorable to having it actually heat. Where does the heat come from? The buildings themselves, and then the fact that the ground's warmer, or a river, or a well, or the sewer, as is becoming more and more talked about. And that you change in your mind in the building, now I can dedicate the building to being more efficient because I'm going to interface my heating and my cooling and my water heating and my discharge water to the sewer, and maybe my sprinkler systems, and maybe my irrigation system, because you can tie it all together. This is about heat capture is the biggest resource that we have, driven by our own comfort. There's a woman from Africa in one of the seminars. She says, "I don't understand why everyone's against us using gas. It's very noble of you to say don't use gas, or use less because you have it. We don't have it." United Nations Cool Coalition says the good news is we're trying to get cooling. The bad news is it adds heating. We have this, we keep heating the environment. We keep using more electricity. You hear arguments that say if somebody has a whole house air conditioning system, if they put in a heat pump, that they'll use less energy. What if they weren't air conditioning their building? What if they weren't air conditioning their home? They only had one room that was air conditioned. So there's infrastructure issues, and they need to be addressed together. When I showed you that first slide about power going up with electric consumption, the last gas industry meeting that I attended, what was the discussion by them? Resilience. Why doesn't anybody understand we need resilience? The purpose of this presentation is, what are we doing about consumption? And consumption can go down if we have access to a thermal energy network, because we'll cool better, we'll heat better, we'll share energy, and we'll green that network with what's available locally and drive it locally, that it comes from what we're doing. Inside the building, we're sort of lucky. We're not a really big cost of your new construction budget. And there's a lot of focus on how much we're actually doing or not doing, and how much we're rejecting, and how much our equipment is using energy, and that'll be discussed all over the building. But there is real opportunity when you start thinking, well, my building doesn't do this, but another building is doing this. And we don't think about districts and throwing in fast food franchises when all of a sudden you go, wow, they're doing a lot of heating and they're throwing away a lot of heat. and they're using a lot of gas, and how can we stop that, or how can we help it? You look at a laundry, you look at an ice rink, you look at a grocery store or a restaurant, a multifamily. When NYSERDA first started trying to push using community loops, they hired consultants to look at just putting geothermal in the gas right-of-way. And one of the things that came out of that report was it's going to be very difficult to design a 100% geothermal ground loop because we don't know what the loads are, because everything's going to change. It's difficult, not impossible, but it adds to cost if you're trying to do 100%, then make it safe, then make it safer. The purpose of a thermal energy network is we're going to use less. We're going to take pressure off the grid for everyone else that's in the grid as we do our buildings. And we look inside the building first and then among buildings second. It's a lot easier with a campus situation. It's one owner, they want to do it, they're thinking about it. They can do 100% geo, they can do geo farms, they can rotate them around, they can augment it with whatever they need in order to get the heat. I'm talking about, can we make campus advantage available in neighborhoods? The other part of it is it's bidirectional, so any DX cooling equipment works better. Any heat pump heating now isn't a matter of a COP of 2 that means it costs half as much to heat this building than it would if you were doing 100% electricity. Now the COP is high enough, 4, 5, 6 simultaneous, that you end up, it is less cost than gas. It is using less gas. It is taking individual gas lines, run around to every room, and bringing it back to that campus logic. It's centralized. Maybe when they build a new school, or when they tear out an old strip center, or they look at a big mall, and they look at this and they say, hey, we can put a district in here. We can't do it instantly, but we can do it one building at a time to a plan. And that's what your city planners and your utility people need to understand. Let's work together, because we're all interconnected. And not everybody has the same thing at every case. So whatever the building, the more diverse the buildings, the better. The water's going past them at 5 miles an hour. All they do is heat or cool it. The next one heats or cools it. The sizing is so that it will not go over a certain limit, and when it gets to that limit, you throw it away. If you're consistently needing to reject heat, then that building will use all your heat, and then when we can't use it, we have to throw it away until we figure out another plan. We figure out another way. There are 13 manufacturers of water source heat pumps in HRI. This is not about only using water source heat pumps. This is about using every type of HVAC that we can. This building has rooftops. I don't want to tear my whole building apart. Fine. As part of the development of this network, when your equipment's going to be replaced, we want you to go to water. And then he says, you know what, I'd really rather have that space on the roof. I'm going to put equipment inside, because I'm not going to have to invest in infrastructure to get greener, to fight energy efficiency. I'm going to apply all the equipment that we already make. And with what new innovations come, the better it's going to be. But it's not just the only answer is a heat pump. It may mean that the only thing that's going on is your air conditioning is what we need. We need your air conditioning heat captured to decarbonize the next building. It's all about heat capture. We can't capture it if we just throw it away in the air. And if we have to deal with this kind of temperature changes, how many people buy a car and know that it will operate at 5,000 RPM, but you're going to operate it at 5,000 RPM during a snowstorm, during the worst possible day, during the hottest day? Heat capture to advantage and to a plan. So it's being done. Multiple states are doing it. One of the issues that we fight, or that I think needs to be looked at, is we do have utilities that are looking to develop geothermal communities and using the cost of a geothermal community to say it's a bad idea. I'm saying that's because you're trying to do 100 and something % safe system versus this is a startup to use less. This is a plan to use less. This is a plan to green a network. This is an opportunity for revenue-driven, not incentive, rebate-driven. That helps, but revenue-driven for the investor, for the owner of this bidirectional network. Financial sustainability. You don't have financial sustainability when, and I hate to pick on them, no I don't, putting solar collectors on people's homes, especially in underserved areas. Who replaces the solar collector? I'm not worried about the panels. Who replaces the wires? Who replaces the controls? What happens if I get a big storm? Those are things that can help individually, but what do utilities say? Well, it'd be okay if your solar collector doesn't work, then don't come to me and say you want power. It's not, I've been talking about the sewer district. It's not the sewer district going around saying, hey, we're having trouble handling everything, so we want you and you and you in the back and you over here, we want you to put in septic tanks so you can take the load off of our central district. Say, what are you talking about? So I'm saying we have to work together. And we don't need more and more monopolies. We don't need an electric utility providing a thermal energy network and now they got total control of you. It's water in the street. It means less electricity, less fuel, and higher efficiency and lower cost. In the code, which is being worked on by IATMO, it's called a 5th generation. You know, 1 was hot steam and 2 and 3. The 5th generation, the key to it is bidirectional. And you get rid of issues about thermal losses, you get rid of issues about what the delta T has to be, but you can take all those same logic, all that same logic that goes in a district system, and you can use ice if that's what you have available. You can use gas if that's what you have available. You can figure out how to interface with all the different ways that I said you can green your network. So who owns it? I told you I was going to give you one example, and I emphasized that one example being the water jurisdiction at least manages it. The water jurisdiction is at least someone that is on your side about what the cost of power or what the cost of gas might be. They have right-of-way. They have the stationing logic to go ahead and do this. Do they know about it? That's my job. I'm trying to get them to know about it. So every utility can do it. Every developer could do it. It's like an annuity for a developer. He owns this infrastructure. For you as an owner, you pay a fee. It's like he's the energy services provider. How many times have you paid for your phone with your energy services, your phone services provider, you know? So I said, why water? I like the idea of the sewer district being involved. Municipal, and I call it IO10. Who's the investor? The investor has the simplest infrastructure, longest life, simplest to maintain, no real issues with it at all. This pipe lasts 100 years. And everybody that runs a utility and every contractor that puts pipe in a building can be part of this. It's a lot of jobs at every level, from the planning, the scoping projects, and working through it. So attention, city planners and developers, and talk to your politicians about, let's quit polarizing. We need resilient resources and we need solutions, and this is one. Any utility can do this. It's a revenue source. It's for those people that make money with long-term investment. How do we start? Pretty simple, actually, because we're not trying to do 100% safe. Local utilities know what's going on inside their areas, but the easiest place to apply this is new development. Where there's going to be a new area go in, where there's going to be a part of downtown that's redone to something else. It's when they're going to redo the sewers, we can put this in that same ditch. The government agencies, the information source, CBEX, these are all averages, and the nice thing about a thermal energy network is you are trying to get the energy down. You're not trying to say use more, you're trying to get it down. And helping this, NREL and Lawrence Berkeley just put out on the internet end-use load profiles for typical buildings. Now you can, without getting into the individual utility bill, if you're going to lay out a district, you can get a rough idea of what's going on. The organization that I work with has a program called BEST. It's free. You open that up and you pick a building and you pick a location, and it gives you examples of what the energy consumption might be there. Then it allows you to change hundreds of things, which the next presentation, by the way, to make it work for you, to make it more accurate. But you're not trying to be 150% safe. You're looking at, how do we do makeup? How do we do backup? How do we do startup in a just transition for everybody? So, beneficial HVAC and water, not just water heating, sewage water, irrigation water, sprinkler water, water stored in the ground, rain capture, rivers, sewers, other buildings, among buildings. That's what we're looking at. Benefit to all, benefit to the owner of the building, geared toward benefit for the owner, not benefit for the utility, not even benefit for the investor-owned network. They're looking at revenue. We're looking at cost avoidance. We want to spend money on our building and making it productive. That's what this enables. Local, think local opportunities. You don't have to look at it with a magnifying glass. You just have to look at it. And you have to know that there's an opportunity. Secretary Granholm likes to talk about there's no silver bullet. She refers to it as silver buckshot. My latest shot over the bow to her was, I'm not talking about silver buckshot. I'm not talking about a silver bullet. I'm talking about a silver net. That the building nets energy in the building. Then the network nets energy amongst the buildings. And before we buy any new energy to heat it or cool it, we've applied plenty of thermal opportunities, which may be everything from geothermal loops to rivers to canals. When a city, Oklahoma City, put in a monstrous canal, they flooded the river. We're now an Olympic training site for canoeing and kayaking. They built a new development down by the river. It's all geothermal. You go in, you're buying basically a small homes, smaller homes, all laid out in a network, all common water, all common sewer, all common energy efficiency in the street. Because they knew about it. Thank you. I think about it a lot. And the reason I think about it a lot is because these kids are mine. And they're beautiful. I have a few minutes. Any questions?
So, I I see where you're coming from.
Good.
But understanding that one premise of geothermal in an application has been balancing the needs within a building, so that if you're just using ground source without sharing amongst buildings, that you essentially can subtract heat or add cool in the heating season, and then you can add heat in the cooling season in order to balance what you're doing to the geothermal situation. And that requires you to invest in some kind of infrastructure in order to access that. But for a lot of people who have both cooling and heating loads that can balance over the course of a year, I wonder if that still is potentially more practical than assembling, the kind of connections here.
Yeah, and what he's talking about is load balance, and when a lot of buildings, in my experience, that put in they want to do geo, they do what's called a hybrid, and the hybrid is the idea that I want to get rid of my boiler. More likely in the north it was, I don't want a cooling tower anymore. But they sized the loop, the ground heat exchanger, to take care of the smaller load because of money. It costs a lot of money to put those ground loops in. Not necessarily because it's expensive because of the pipe. It's expensive because of somewhat of the design, and that it's not happening enough. In Oklahoma, there's a rural electric co-op that actually owns individual geothermal loops for homes. And Boyd's got a really kind of a cool idea in that, yes, they have to run a manual J before they can put it in, and they look at who's going to do the ground loop and all that stuff, and where's the separation between the homeowner and them. But he said, don't get overly critical about running your load profile for a home, because right now there may be 2 old people like my wife and I living there, but there could very well be 2 families move into this house the next time. So we do look at, you can look at with a home what the total exposure would be. And we in this industry run into issues where people have put, oh, they got geothermal, and they say, oh, now the loop's dead. Well, it's like any coil. And the thought process of using geo in a thermal energy network is it's a coil. It takes part of the load. The nice thing about these loops is you can say, oh, this is colder and we want it to be colder, so go through that. We want it warmer, so go through that. We want it to get back to where we were. You're hotter, you're colder, use this resource. And the part that I didn't get into is that because this is a network, on startup and makeup and management, can you start load sharing among buildings? Oh, this building's empty. We learned some issues with that, where COVID caused Florida to use more gas than ever in the summer because they needed it for dehumidification. It's like in Canada when we switched out to higher efficiency light bulbs, they found out they had a bigger heating load. These unplanned consequences, we don't know about. So the goal here is let's put in the network and then let's green it. Let's understand what we're doing. Let's understand what the possibilities are and get ready for change, but let's use less. We know overall consumption is going to go up. How do we also know that if we capture heat, that's decarbonization. We also know that at those temperatures, we cool more efficiently. And it makes perfect sense that if I can't do all of this inside my building, I can do it among buildings. So to my earlier example, the electric utility was losing $200 per home annually. But by owning ground loops and getting winter electrical use, and some of them selling backup gas generators, which I have to confess, I've been vice president of a couple of different geothermal companies, and I have geothermal, and I've had geothermal in my home for 30 years. But I have a natural gas backup generator. Because where I moved to, the power was not reliable. And now the only way I know when the power goes out, because it still goes out, is my timer on my oven starts flashing. Otherwise, I don't know. I still use less, and that's one of the things that I think we have to focus on. This is about a way an owner gets the cost off his back. If an owner only has electricity and air, then we in this building have to help them, give them the most efficient air source equipment that we can. It's only responsible. Not everybody has everything. You know, we say, oh, give up gas. It's noble to give up gas if you don't have it. People that have gas don't want to give it up. People that understand that industry look at it and say, oh, the best you can do is a 2 COP. 2 COP isn't break even, that's half. It means I'm going to pay twice as much as I did before. But now you come in and you say, look, are you heating water in your building? Oh, I'm not. This guy is. He's heating 40 gallons of water per day per person. Maybe you can sell him your heat. Maybe you're part of a homeowners association and you say, I want that. That's my goal. Is that business owners and homeowners say, I want that. You say infrastructure, infrastructure, infrastructure every day. Well, damn it, give me some infrastructure. Don't tell me you'll give me some money so I can buy infrastructure. It's why you see community solar. I think you're going to see more and more. There's more and more talk about community geo. I'm saying hybrid, because what's going to change? Individual owners are going to change. How they're going to operate their building is going to change. The purpose of the building is going to change. But here's a solution to get a hold of consumption and make it easier for a manufacturer to make equipment that functions here instead of equipment that has to function here. And traditionally, the way we've always done it, equipment that cools really good, equipment that heats really good, so you have to have both. Connected to a thermal energy network, now every piece of DX equipment can either heat better or cool better. It's heat capture is decarbonization. And if you don't capture it, then you've got to buy both. You got to throw the heat away and deal with the heat island effect, and then you got to buy some. You got to go somewhere to get the heat. Because what do heat pumps do? They move heat. They burn electricity. And if they're connected to water, they're a hell of a lot more efficient. Thank you.